buoyancy and Archimedes principle. Learning objectives are: what is buoyant and buoyancy force? When a body will sink or float in fluid, how to calculate force of buoyancy? We will know the answer to these questions very shortly. Take 1.5 kg of mass of gold brick and take its weight in air. See, weight of this gold brick in air comes out to be 14.7 Newton. Now, take the weight of similar object in water. Its weight comes out to be 13.9 Newton. Why this difference of 0.8 Newton? Just see. This difference of 0.8 Newton is explained by Archimedes principle. Okay? Just I have said it is weight of the fluid displaced by the body, and it is called force of buoyancy. Buoyancy force depends upon the density of fluid. Air has very less density, so buoyancy force is negligible in air. As we can see here, in air buoyancy force is only 9.1 into 10 to the power minus 4 Newton. So for all practical purposes it is ignored. Okay. Now, before arriving at formal definition of Archimedes principle, I would like to talk about Archimedes challenge during those days. In fact, Archimedes' task was to find whether the crown of king was pure or impure. Just see. It was the main challenge for Archimedes. So what Archimedes did? He took the measurement of spilled water from the water vessel when pure gold was immersed. In second step, he again take measurement of spilled water by immersing gold crown, and he took the difference of spilled water and what will be the test, whether of purity or impurity. If there is no difference in quantity of spilled water, crown would have been pure, but actually crown was not pure because gold crown displaced more water than pure gold. Now come to the formal definition of Archimedes principle. It says, when a body is completely or partially immersed in a fluid, the fluid exerts an upward force on the body, and this is equal to the weight of the fluid displaced by the body. Here there are two terms, completely or partially. Taking these two into account, we split Archimedes principle in two parts. Part 1, a body immersed wholly in a fluid experiences a vertical buoyant force equal to the weight of the fluid it displaces. That is, buoyant force is equal to weight of fluid equivalent to body volume. Just see, body volume. That is, we have to take weight of fluid, and weight is equal to mass of liquid into acceleration due to gravity, and this mass is equal to density of liquid into body volume. Remember it. And of course acceleration due to gravity. So finding buoyant force, we have to take weight of liquid equivalent to body volume. And part second, when it is partially immersed, a floating body displaces its own weight in the fluid in which it floats. Floating bodies are a special case. Only a portion of the body is submerged, and buoyant force is given by weight of fluid equivalent to displaced volume. Whatever part is submerged, we will take only that volume.